Okay, so we are going to talk today about factoring by grouping. So first of all, you need to be able to group your polynomial into sets that are the same. So you have to have like 4 values or 6 values. I'm going to be grouping my set into groups of 2. And then essentially now what I've done is I said, okay, so I have 2 groups, and what the next step is to do the GCF of each pair. So doing the GCF of the first pair and the GCF of the second pair. So if I look at the first pair, x cubed minus 4x squared, and I'm looking for my GCF, I don't have a common number factor, but I do see that I have x cubed and I have x squared. So I do have a GCF on the variables of x squared because there is an x times x in each set. So now this is pulled out of the first pair, and then what is left over out of that first pair is x minus 4. Then I do the same thing for the second pair. So the second pair, 3x minus 12. GCF of that pair, I have a number GCF, so 3 divides into 3, and 12 is also evenly divisible by 3. So plus 3. Be careful on this. This is still an addition problem. At the top, we started with addition, so we still need an add or subtract sign in the end. So I'm going to have plus 3, and then what comes out, 3x divided by 3 is x, minus 12 divided by 3 is minus 4. And what you should notice now, if your problem actually does factor by grouping, and if you did all your steps correctly, then you should see that the leftover factor set is identical. And that is actually what has to happen to make this work. Must be identical. If they are not, okay, if that is not an identical set, then essentially your problem is not factorable by grouping, or you made a math error somewhere. Because the next step is to basically say, okay, these are the same, so they're going to pull out into their own factor of x minus 4. So that's what I've pulled out. And then what I'm looking at, my other factor comes from what did not get pulled out as the new GCF. So when I'm looking at this, if I look at the first set, x minus 4 got pulled out. I should be able to see that x squared did not. So x squared is my first term in my second factor. And on the second set, x minus 4 pulled out. And I should be able to see that 3 did not. So 3 is the second term in my second factor. So now I've gone from an expanded set with no parentheses to a factored set of x minus 4, x squared plus 3, and that is my answer. So factoring by grouping should give you a factored set with 2 multiplied factors. Okay, let's try the next set. So on the next set, 4y cubed plus 2y squared minus 6y minus 3. I group the first pair, so two terms grouped together. I group the second pair. On the second pair, notice I have a minus here. One of the rules for factoring by grouping is the symbol in the middle should always be a plus, which means that negative needs to turn into a negative 6y. So instead of minus, I want negative 6y. So essentially I'm taking minus 6y and I'm turning that into plus a negative 6y with whatever grouping, okay? So those are equal, and that's what I'm doing. I always want it to be positive in the middle. So in the middle, always a plus sign. And so that means if I need to change that sign over, so from minus 6y to plus negative 6y, that is what I do. So then I just do the same thing I did before. What is my first set? 4y cubed plus 2y squared. Looking for my GCF. 4 and 2, the common number is 2. Y cubed, y squared. I have a y squared on each set. So my GCF for the first pair is 2y squared. The factored remainder is 2y plus, and then notice here I have 2y squared divided by 2y squared. That's a number over the exact same number. So my answer for the second term is going to be 1. All right. Second pair, minus 6y minus 3. My first term is negative. One of the GCF rules is that whatever your first term is, your GCF sign matches. So it's got to be negative. And then I have 3 and 6, which both divide by 3. I do not have a y on both of those terms, so there is no variable on that one. So now on my main problem, minus 3, making sure that I'm still doing an added subtracted problem because that's what I'm starting with. In that second set of parentheses, once I have factored out the negative 3, I'm going to be left with 2y and then negative 3 over negative 3, positive 1. Again, now I'm looking for, are these the same? So I have 2y plus 1, and I also have 2y plus 1. So check, they are the same. So now what happens to them? They pull out in front as my new GCF, 2y plus 1. Okay, so what I did not pull out becomes my second factor. So what I did not pull out is 2y squared out of the first set. What did not pull out is minus 3 out of the second set. So then that is my final factored answer, quantity 2y plus 1 multiplied by quantity 2y squared minus 3. And I have successfully factored the original problem. So once again, up on top, this is expanded, no parentheses, and then my answer, 2 sets of parentheses multiplied because my goal is to factor it, which means turn it into a multiplication problem. Okay, let's look at this one. So we're going to go ahead and start by grouping it. Mostly I'm going to group right here because this is already a plus in the middle. I already have a plus in the middle, so I don't need to worry that it's minus and then I need to change my signs. So I'm just going to go ahead and group this. First 2 terms, second 2 terms. So what is common out of the first 2 terms? 4v cubed minus 14v squared. 4 and 14 both divide by 2. My GCF is positive because the first term 4 is positive. Okay, and then I have variables v cubed and v squared. So my GCF for the variables is going to be v squared because I have to have v times v to pull something out. So what am I going to get here? It's 2v squared multiplied by 4 divided by 2 is 2. V cubed divided by v squared is v. Minus 14 divided by 2 is minus 7. V squared over v squared. Essentially, that's canceling out entirely because it reduces out to 1. So there is no variable on the second term, which is what should happen because if we have variables on everything, in the end, one of those variable terms should turn into a regular number. So let's look at the second set, 12v minus 42. And 12 and 42 both divide by 6. So remember, I need the plus sign. So I'm going to need a plus sign because since I have addition up here on the main problem, I'm going to need addition on my factored problem on my next step here. And then my GCF from the second set, which is going to be 6. What is still remaining is 12 divided by 6 is 2. The v, 42 divided by 6 is 7. So 2v minus 7. And I do see that I have 2v minus 7 and also 2v minus 7. So those are the same. So I'm going to pull them out as my new GCF. So out in front comes 2v minus 7. And then what did not pull out? 2v squared plus 6. So I'm looking at this and I'm noticing something, which is 2v squared and 6. These actually both divide by 2. So 2 and 6 divide by 2, which means what had happened is I missed a GCF up at the top because otherwise I wouldn't have that common factor. So I'm just going to factor that out right now. So now what I have is 2v minus 7 times 2 times v squared plus 3. So this is the factored form, but usually regular number factors like 2, we normally don't write them inside the other factors because sometimes they can get lost. So normally that factor there will come out in the front. So in sort of our standard order, we would write 2v minus 7 as our second factor, v squared plus 3 as our third factor, and that would be my final answer. It does not matter what order you write these factors in. That reason is because 2 times 3 is exactly the same as 3 times 2. So when I'm multiplying, I can organize it however I want and still get the same answer. So our last problem, based on the one I just did, I'm looking at the 6. I'm looking at the 6, the 2, the 36, and the 12. And I'm seeing all of these actually divide out by 2. So I'm going to start with pulling a 2 out as a GCF. So I pull out a 2. I'm going to be left with 3q cubed plus q squared r minus 36q. Oops, I made a mistake. Got to divide through everything. So 36 divided by 2 is 18q minus 6. So on a problem like this, I don't want to be having to deal with the 2 right now. So I'm going to basically circle it, draw a little arrow down here so I don't forget that there's a 2 out there. And then I'm going to continue onward with my regular set. So working on the actual 4 terms. So grouping in pairs of 2 again. 3q so 3q cubed plus q squared r and then I have a minus, so I'm going to change that to a plus. Put the negative on the 18 minus 6. And actually, I'm looking at this and I forgot this r, so I'm going to stick that in there. All right, so now first value set. I don't have any common numbers, but I do have a q cubed and a q squared, so I'm going to be able to factor out a q squared. So q squared comes out. And then left inside my parentheses, once I've factored that out, 3q plus r. Factor out the next one, it's going to be negative. So negative first term, negative GCF. 18 and 6 both have a divisor of 6. Q and R are not the same variable, so that's all I can do. So minus 6. Once I pull that factor out, 3q plus r. Checking for the same, and I have 3q plus r and also 3q plus r, so check. If they're not the same, I made a math error somewhere and I need to go back and find it. Maybe I dropped a negative, maybe I don't have the GCF, so I need to go find it. But since they are the same, then my first factor on my final answer is 3q plus r. And my second factor, q squared minus 6. And then not forgetting this 2, it needs to come back in. So in front of everything, I'm going to write 2 as my multiplier. And then that is my final factored answer. As long as you're careful with your work and make sure that you're doing your pairs correctly, these should be hopefully somewhat straightforward. And that's it for today.